Hello, welcome back to the fourth lesson in our third unit factoring in our grade 10 academic math class. I bailed out with only two examples left to do, and it's because these two are a little bit more particular, and I didn't want this thing to grow to an uncomfortably long size for a single sitting. So, with that being said, let's get down to what we've got going on here. So we've got 20a squared b minus 500b. Okay, so do we have two terms? We do. Is it separated by a minus, a difference? We do. Is the first term a perfect square? It is not. Okay, so unlike the question above, where as soon as you recognize you're not dealing with a difference of two perfect squares, this thing's all over. It's all done. This example down here, we can actually try other factoring methods at this point. So do you recognize a common factor in 20a squared b minus 500b? There are common factors that we can factor out. 20 and b are common to both the first and second terms. So what I'd like you to do here is pause the video and see if you can fill in the rest of that bracket. And if you can get that done, come on back and we'll see where we can go from there. Okay, so you've common factored this already. When you factor 20b out of 20a squared b, you're left with a squared. And when you factor 20b out of negative 500b, you're left with minus 25. So all of a sudden, the resulting, I'm going to change that color, the resulting binomial in these brackets, we can now ask again, is this a difference of squares? We have two terms separated by a minus, and the first and second terms are perfect squares. So now we can go about factoring this like a difference of squares. Let's find the square root of the first term. Well, that's going to be a. And let's find the square root of the second term. That's going to be 5. And now we can start to populate some brackets here. Now again, I say this anytime we do common factoring and then we go on to do more factoring in a question, we can't abandon that 20b. It has to continue along down the question with us. Since if we were to expand our answer back out, we need to get what we started with. And if we just drop 20b out of the question, we're never going to arrive back where we started. So, first bracket, or the brackets rather, the first values in the brackets, that's the square root of the first term, which is a. Last values in the brackets are the square root of the last term, which is 5. One gets a plus, one gets a minus. And there you go. So we can common factor something out of these binomials, and then the resulting binomial could also be a difference of squares that we could then go on to factor. So I guess really with example G and H that we're going to look at next, the thinking is really that sometimes it's not just a single type of factoring that you're going to be doing. Sometimes you common factor and then you can do a difference of squares. Or sometimes, like in yesterday's lesson, we can common factor and do a tricky trinomial. Or 2 days ago, we can common factor out and then factor a simple trinomial. So factoring, I guess, is don't always assume that it's going to be over after one type of factoring, I guess. Okay, let's go have a look at H. H is 16x to the exponent 4 minus 1. Okay, how many terms do we have here? Two terms, separated by a minus. First term is a perfect square, and the second term is a perfect square. I sort of went over it fairly quickly up above. We had an example with an x to the, you don't have to write this part down, but x to the exponent 4, if we consider it, this is actually going to be x squared times x squared, which is why it's a perfect square. I went over it fairly quickly. This would be true of any even exponent that's up there. X to the exponent 3 or x to the exponent 6, for example, would be x to the exponent 3 times x to the exponent 3. So when I see an even exponent on a variable, I know that it will be a perfect square. I realize I went over that fairly quickly earlier without making a comment on it in the first video. So there's your comment on it. Okay, so we have identified this as a difference of squares. Let's take the square root of the first term, which will give us 4x squared. And let's take the square root of the second term, which will give us 1, which is nice. So let's get our two brackets going here. Let's pause the video You guys fill in these two brackets, and when you're done, come on back and we'll see if you got them right. Okay, let's get a look. So the square root of the first term starts each bracket, and the square root of the second term ends each bracket. One gets a plus, one gets a minus. There we go. Looking good. But as I said in the question before, is there more factoring that we can do here? If we look at our first binomial, well, that's 4x squared plus 1. So that's not a difference of squares because it's not a difference. However, our second binomial, 4x squared minus 1, that is actually another difference of squares hiding in there. It's two terms separated by a minus, and the first and second terms are perfect squares. So we're actually going to do another level of factoring here. We're going to look at the square root of our first term in this new resulting bracket here, and that will give us 2x, and we're going to look at the square root of the last term, which again is 1. So now we're going to actually have, I think I have enough room for it here, we're actually going to have 3 brackets going on here. The first one is just a recopy of that result of our first difference of squares, the 4x squared plus 1, but now we've taken this guy and we've done another difference of squares on it, and that's what's going to go in these two brackets. So let's hit a pause here, see if you can figure out what's going to go in those two brackets. When you have it done, come on back, and we'll see how you did. Okay, here's what's going to go in those last two brackets. Starts with the square root of the first term, which is 2x, ends with the square root of the last term, which is 1. One gets a plus, one gets a minus. And I guess if we're being diligent, we can look, are there any more differences of squares that we can work in there, or any other type of factoring that we can see? And there is not. So there's your monstrous final answer. And that's the end of our lesson on differences of squares. The next lesson is really, and I'll just sort of scooch ahead here so we can get a look at it. The next lesson is really just a summary, sort of a, how does all the factoring tie together, and in what way should we look to factor a question if we're not given guidance like, hey, we're doing difference of squares today, hey, we're doing simple trinomials today. If you don't know necessarily what type of factoring is expected, how can we work through it? So that's going to be our next lesson, and that's really the end of the unit. So good luck with the homework. The homework obviously is just up here. It's working on the Factoring Tricky Trinomials and Difference of Squares worksheet. Good luck with that. If you have any questions, you can email me. Otherwise, yeah, good luck with your homework. And we'll see you in lesson 5.